Probably the hardest part of this chapter is the naming of the organic compounds. And the book gives you several examples, but here I'm going to walk you through some others. The first thing is in that first section, you've got to learn the basic names of 1 through 10 carbons. That's a memorization. Typically, those are, if they're straight chain, like 3 carbons in a row. We often don't draw the hydrogens. We call this the carbon backbone, but it would be CH3, CH2, CH3 to make our octet, or we could draw it out and make it look more like a Lewis structure with all those bonds, and that is the correct number of valence electrons for this structure. That would answer the question, what's the Lewis structure of this, like we saw in the previous module. So that would be propane. 3 carbons, propane, memorize. So you've got the table of the 1 through 10 carbons, what the name would be, and you have to know those or have that table handy when you take your quiz and do your test. It starts getting trickier when there are double bonds or triple bonds. Double bonds require an "ine" ending. Triple bonds require an "ine" ending, Y-N-E, pronounced "ine." And you number where that bond is. So if I have a straight chain, 2, 3, 4, 5, let's say I have 5 carbons in a row and the double bond is here, this is on the 1 carbon. So 1, 2, 3, 4, 5. So this would be a 1. 5 is pent. If it were all single bonds, it would be pentane. With a double bond is pentene. So this is 1 pentene. But if the double bond is in the 2 position, that is a different molecule. It has exactly the same atoms, exactly the same number of valence electrons, but it's an entirely different molecule because the double bond is in a different place. It has different, maybe similar, but different physical properties and chemical properties, and it will behave differently in different reactions. But now I name that as 2-pentene because it's in the 1, 2, 3, 4, 5. It's on the 2 carbon. What's a little trickier as we're stepping forward is if I have 5 carbons in a row and the double bond is here, that is not the 4th carbon. That is the 1st carbon because I number them. I can number them backwards, I can number them up, I can number them down, just depending on what the chain looks like, but I number them so that the double bond is in the smallest position. So this is still 1 pentene, just like I saw. These are the same molecule. These two are isomers. Same number of atoms, same number of valence electrons, but they have different structures. All right, so the bottom one is still 1 pentene. If there's a triple bond, it's a pentyne. If it were 5 carbons, 2, 3, 4, 5. And if the triple bond were here, that would be the 1, 2, 3, 4, 5. That would be the 2nd carbon. That would be 2-pentyne. If it were here, 1, 2, 3, 4, 5, that is still 2-pentyne, because again, I'm going to number it such that the triple bond begins at the smallest carbon. So these two molecules are exactly the same molecule. They are not isomers, they're the same molecule. But if I had 1, 2, 3, 4, 5, actually I've already got it. These two are I don't already have it. This is 1-pentyne, and it is an isomer of 2-pentyne.